All right, so what population could this sample represent? And we talked about that already. The sample that we were representing was all SOA students in stats. And when we analyze the results from the entire class, so on the left column, talking about the entire our population, the method was considered a census. And then we saw that example of a simple random survey about the different dialects around the U.S. And here is just a table to contrast the two. So we have sampling would be part of the population versus census would be the entire population. Sampling would involve a random device. So that could be a coin toss, a table of random numbers, a random number generator. A census then would be a survey that's distributed to everyone. So the best way, or the best understood responses of the entire class. To best understand responses of the entire class, which would be a representative sample. Circle the best answer. So take a look at those 4 options, read over those, and decide which would be the best representation of the entire class. It's fairly obvious. What did you decide, Gigi?
D.
D. I think everyone I saw was circling D. So sampling half of the students at random would be representative. Sampling just the students from Fairfield High School or just the vocalists or just the male students would not represent the entire population. So representative sample, that's going to be one of your terms. You'll have a vocab assignment I'll assign on Monday, but if you want to work ahead, that will be on your vocab list. And it's a sample that reflects as closely as possible the relevant characteristics of the population. The relevant characteristics of the population under consideration. So doing a representative sample helps eliminate unintentional selection bias. And representative sampling is a sampling procedure for which each possible sample of a given size is equally likely to be the one obtained. So all of the students on that list were equally likely to be chosen by that random number generator. And when we talk about a bias sample, that's a sample chosen to represent the population and either intentionally or unintentionally it includes only a select group of members. So for example, if I were trying to make a case to the city of Hamilton that we need more art venues for our city, right? They're doing all this revitalization, they're hearing the ideas of the public. So I did a survey of students at School of the Arts. Do you see the bias there? Okay, so we would have a biased sample because it is pretty obvious that there would be a result different than the general public. You could say that that would be an intentional bias or a convenience bias because it's simply convenient for me to ask everyone at School of the Arts because we're here to get together every day. So that's bias. Before we hit this next example, there are two definitions I wanted to point out, so you'll have to kind of squeeze them in here. The phrase with replacement and without replacement. So if I'm doing a simple random sample and I replace the items, so if my random number generator was able to generate the number 19 twice, that would indicate I have replaced that number and can pull that number again. Okay, so I could pull that same person that was a dancer again. It wouldn't really provide the feedback that I was looking for if I do with replacement. It's actually less common to do with replacement. The acronym we use is simple random sample with replacement. It's kind of long. Simple random sample with replacement. For without replacement, that's the standard. So if it doesn't say, we would assume without replacement, and that's simple random sample. It gets the shorter acronym. And that's the one that's assumed. All right, we'll take a look at this example here. One thing I really like about the examples in our textbook is they're legitimate studies. So you can actually pull out one of those books, and in the back of the book there's just a list of all the different studies that they've done. It's not just made up examples like you typically see in a math book. So this one's on the sampling of the Oklahoma state officials. So in the state of Oklahoma, they have a governor, a lieutenant governor, a secretary of state, an attorney general, and a treasurer. So we're going to consider these 5 officials a population. We're considering this our population of interest. So the first question says, list the possible samples without replacement of 2 officials from this population of 5 officials. So part A, we're just listing out the different possible ways we could pick 2 officials. So when you do this, you want to be organized about it. So I would start with governor and pair governor with everyone, then lieutenant governor, and so on. So take a minute and try and list out all the possible samples.
So is GL different than LG?
It is not. That's the same. Good question. All right, you can check and see. Did you get 10 different possible outcomes? Okay, good. So B, the question asks, describe a method for obtaining a simple random sample of 2 officials from this population of 5 officials. This is a small population, so it's pretty easy to just take little pieces of paper and write down the letters. So write G, L, S, and A on a piece of paper, put them in a box, and draw them out.
But then you're leaving out T.
Did I not say T?
No, you said GLSA.
Sorry, I meant to say T. And T. Okay, so we could just write the letters. That correspond and throw them in a box. And blindly choose 2. And then part C is just asking us, what are the chances of 2 officials from the population of 5 officials? So what is the probability of obtaining any one of those outcomes? What would be the probability of obtaining any one of these? 1 out of 10, right. Because this is a simple random sample, each one is equally likely to occur. So 1 out of 10. D says repeat, but this time use a sample size of 4. So try and do that one on your own.